Begin with a corridor you cannot see.
Not a road of stone. Not a trail of dust.
A corridor of geometry, laid flat across the black, so precise that an engineer would nod and a poet would lose their breath. That is where the strangeness lives. Not in the noise, but in the accuracy. We thought we had time to get used to the idea of visitors. In 2017 the sky slipped us a test, and we called it Oumuamua because the name fit the feeling, a scout from the deep. It came in fast on a hyperbolic path, rotated like a dream you can't remember after noon, and then it did the unforgivable thing.
It sped up. No tail.
No obvious jets. No plume to point to and say, there, that's the engine. The data simply refused to be domesticated.
Some of us said, we don't know, and meant it.
Some of us stitched new versions of old models and hoped the seam would hold. The right lesson from that season was not an answer.
It was a posture.
Not knowing was okay. Not knowing was the honest beginning. Now the sky has written a new problem on the board and signed it with a name that sounds like a pillar, Atlas. 13th in a catalog more imaginative than it used to be, an interstellar stranger with paperwork that reads hyperbolic, and a path that makes your eyebrows lift on their own. The first glance comforts you.
Gust from the outside. Open flight. Noting wie havent imagined 100 times.
Then the numbers lean forward, elbows on the table, and they ask for your attention. Picture the solar system the way sailors picture a sea in their bones. A flat plane where the heavy bodies circle like cautious ships, each on its own lane, in roughly the same plane, the ecliptic. That flatness is the signature of our birth. It is the fossil of a spinning disk that collapsed and lit itself. Visitors, if they come from anywhere at all, should come at random.
From above. From below.
Slice through the sheet at an angle, cross once, and go. That is what randomness looks like when it keeps its manners. Atlas declines to keep those manners. Its inclination is 5 degrees.
5. Not 50.
Not wildly off the plane.
A gentle tilt.
A near lie-flat ride along the ecliptic, as if a rock from the far side of elsewhere had pulled up a chair to our dining table and knew which side the fork belonged on. The odds that you get that kind of alignment by accident are not zero.
Noting real is zero.
They are the kind of odds that make statisticians feel like they need a shower after they defend them in public. The feeling is not proof. The feeling is a clue that you might be standing at the edge of your old map. It gets worse or better, depending on how much uncertainty you can swallow. The sequence of encounters looks like a lesson plan.
First Venus. Then Mars. Then Jupiter.
A neat trio, each pass angled the way you angle a spacecraft when you're stealing a little speed, paying with trajectory instead of propellant.
No aerobraking, no atmospheric beat, no messy tricks, just gravity doing slow, elegant accounting.
If you've ever sat inside a mission design room and watched weeks of people time collapse into a number that says, we can shave 100 meters per second if we meet the planet here instead of there, you know what this looks like. It looks intentional, without requiring intention. It looks like optimization wearing a blindfold. People you'd expect to smile shrugged first. Coincidence, they said, because the sky is big and time is long. If you flip a coin long enough you will get 100 heads in a row a few times in the history of flipping. Other people went pale. They went pale because they were not imagining saucers. They were imagining capture windows. They were imagining lost chances. They were imagining the taste of regret, which in science is always the flavor of data you could have had and didn't. Planets and paths are only half the story. The light matters. The light is where nearly everything we know begins. Photometry teams did what photometry teams do, they turned brightness into estimates. They assumed a dark albedo, the kind primitive bodies tend to wear like a uniform, and they let the math tell them a diameter. 20 kilometers if it's that dark, they said. Maybe a little less, maybe a little more, but big enough to be the largest interstellar guest we've measured, big enough that we would feel it in our models like a weight on the wrong shelf. A giant ought to leave a mess when it warms. A giant ought to grow a shawl.
Jets, dust, a coma you can't ignore.
For days, there was nothing of the sort.
No plume. No fan. No coma.
A body plunging through sunlight as if heat does not concern it. A cold thing acting like a cold thing, until suddenly it didn't. When activity finally whispered onto the images, it came late and sideways. The material drifted in strange arcs, sometimes curling in a direction that made no sense if the sun was the only finger stirring the pot. The models we teach undergraduates sighed and asked for mercy. Fine, they said, let's add a magnetic interaction here, a different grain distribution there. Fine, Let's soften the edges of our assumptions until the graph stops looking personally offended. Every tweak opened a new seam. Every seam revealed new strangeness. The clock, unsentimental as ever, rolled toward perihelion, and the worst timing wrote itself into the timeline. When Atlas would be most baked when the volatiles, if there were volatiles to show, would perform their chemistry for our lenses, the object would be hidden behind the sun from our line of sight. The best window would be drawn shut.
Hubble was out.
Webb, with its exquisite fragile eyes, was designed with a sun avoidance angle that keeps it alive and keeps it honest. You don't point instruments like that too close to the furnace. We were left with an old feeling that technology does not protect you from, the ache of not being able to look when you most want to. So the ground game began. Spectrographs into every available slot. High-cadence light curves squeezed into nights that begged for sleep. Astrometry so precise it feels superstitious. A whiteboard divided into 3 columns: dynamics, composition, geometry. Dynamics, hyperbolic, small inclination, sequence of planetary passes optimized for speed without ever touching a drop of atmosphere. Composition, no gas at first, then a faint halo, brighter than the size model likes, a chemistry that smells like the old deep-water ice, silicates, complex organics. Geometry, tiny brightness modulations that refuse to dance like rubble, a phase function that whispers about smoothness where you expected roughness, a glint that lives only at certain angles, the kind metal loves and pores hate. You could feel the tone shift in private calls. The formal write-up stayed careful like professionals in good suits. The eyes on screen were less tidy. If it's a giant stone, why does it move with the grace of a pilot who has practiced this approach 100 times? If it's a comet, why does it wait and then wake, and why does the dust arc in ways that point to something more than sunlight? If it's ancient, why do parts of it reflect like something honed? None of this is the same as a conclusion. But all of it together is the sort of cumulative unease that usually preludes a leap in understanding, or a spectacular confusion that forces a field to clean its own house. The arguers lined up in the usual formation. One side invoked selection effects. Of course we remember the weird ones. Of course they cluster in our memory. The other side said, selection effects are not a force of nature.
They are a footnote.
When deviations stack like plates, you do not scold the waiter for carrying them. You get a bigger table. Somewhere inside the data, the composition began to write its own lyric. The spectra whispered old, not metaphorically, but literally. Ice that had not been cooked the way the solar oven cooks anything that lingers. Organics that retained a signature indicative of regions far from the radiation bath of dense star fields. Silicates in a mix you could trace to neighborhoods beyond our sun's birth cloud. This did not calm anyone, because the preservation seemed too perfect.
Not pristine as a headline. Pristine as a physics problem.
As if the object had spent eons under a kind of protection.
A natural vault?
A trick of trajectory? Or a design decision written into the rock by time itself? Then there was the light's peculiar way of leaving the surface. Under certain phase angles, the reflection behaved like a room with mirrors instead of rough plaster. You can model that without tin foil. Some glasses, some ice skins, some annealed crusts formed by micrometeorite gardening can glint like that. You can also lay those explanations on the table next to the wild odds of the flight path and feel them jostle each other. 100 natural ingredients can bake one improbable cake. That is not forbidden. It is unsatisfying only if you mistake your taste for a criterion. The small forces crept into the conversation. If you go back in the math to a time before any human had named any of this and you nudge the initial speed by centimeters per second, you can put Atlas where Atlas is now with that neat necklace of encounters. If that is true, then a few molecules burned off at the right times, a few temperature gradients, a few magnetic nudges, could have pushed an object into a corridor that only looks like cunning. Nature does things that look like intentions all the time. Rivers carve switchbacks that would impress a city planner. Crystals assemble into architectures that would flatter a cathedral. We know better than to confuse impression with fact. We also know better than to throw away a pattern because we are afraid of how it will be misused. Which is why the cultural half of this story is as delicate as the science. Reporters, who have to write for a living, reached for phrases you can speak out loud without losing a room.
Gravitational hitchhiking, they said. Interplanetary surfing. Corridor. Autopilot.
Those metaphors are both helpful and dangerous. They make the picture in your head vivid. They smuggle in the idea of choice. Experts, burned more than once, chose adjectives that did not cause fires. They said unusual, noteworthy, high priority.
They refused the A word.
They also refused to pretend that nothing here is odd, because lying is a sin in any language, and in science it is a felony. There is a different, older bruise under the skin. We like to believe that our engineering is unique. That only minds with textbooks can wring efficiency out of the gravitational fields we live among. Then a mess of rock from nowhere comes through and looks like it has taken the same class, and something in us rebels. For some engineers, this is humiliating. For others, it is the purest tonic. The physics is the same whether a human writes maneuvers on a board or a stone writes them with a path.
The sun does not care. The planets do not care.
The fields don't check your credentials before they offer to exchange momentum for time. Meanwhile, inside rooms where nobody claps, the practical questions made themselves comfortable. If we wanted to know more before Atlas left the neighborhood, how would we do that? Intercept missions do not appear when you whistle. They require years of design and money that in most countries is already promised to other kinds of emergencies. You can launch small if you are clever, with sails that drink sunlight for momentum and a payload as thin as a thought, but even the boldest concepts blush at schedules like this. No Hail Mary appeared on a desk with the right stamps in time. We were left with Plan B, which in this century looks like a planet's worth of telescopes and computers and people turning noise into plots into arguments. There is a temptation to think that losing the perihelion window is an omen.
It isn't.
It's an inconvenience, and it is a lesson. If the last decade continues the way it has begun, interstellar interlopers are not going to be one-per-lifetime events. We have already found more in 5 years than we expected in 50. Either our sky sweeping has sharpened into sight, or our models were provincial, or we are living in a moment of luck we will only understand later. The fix for any of those possibilities is the same: build a standing capacity to pivot hard when the sky taps the glass. The past keeps throwing us analogies whether we want them or not. The first pulsar looked so regular that the team joked about little green men and named it LGM-1. The reality-spinning neutron stars ringing like bells with their own impossible densities was grander than the joke. Tabby's star dimmed and brightened and would not settle. The theories of dust did not satisfy the way a good theory should, and we learned to sit with that uncomfortable middle while better instruments were built and better minds aged into their powers. A young star's debris disk vanished on a timescale that models said could not be real, and the case was shelved because we are better at writing new papers than filing old grudges. The wow signal beeped for a minute and then the silence swallowed it. We turned that into a myth because myths are easier to sleep under than unknowns. All of that memory is useful here. Not because it tells us what Atlas is. Because it tells us how we behave when the sky is interesting. You can build a story of pure natural history and not embarrass yourself. Hypothesize an object with a very low albedo, a high thermal inertia, and a surface that has been smoothed by forever. Let it drift for 1 billion years through regions of space gentle enough to leave its chemistry unmolested. Let it take a speed and a vector from some long-ago event that bequeathed it the faintest bias toward our plane. Let small, invisible forces stack over time in a way humans are famously bad at intuiting. You end up with a path that doesn't violate any law, a light behavior that can be cradled by the right combination of textures and angles, and a handful of observables that feel weird because we have not seen that combination before. Every time we have done this kind of exercise honestly in the past, we have wished we had done it sooner. You can also build a story that includes intention, and if you do it without romance you will not be laughed out of every room. Imagine a very ancient piece of technology whose whole brand is patience. It uses no propellant. It leans on the fields because the fields are free. It presents surfaces that manage heat and radiation because that is how you last. It is quiet, because quiet things persist. It does not care to be seen. It does not care not to be seen.
It simply moves.
You do not have to believe that story to let it live in your head. You have to be honest enough to admit that such a story does not break physics and is not just a sugar coating for boredom. Between those two stories lives the one we are writing together now. It is the story of how we find out. It is the story of the new instruments we will justify because this hurt. It is the story of the small missions that will be born because people are stubborn after they are disappointed. It is the story of pipelines cleaned and made public because secrets rot science from the inside. It is the story of better outreach, because badly translated wonder curdles into either hype or cynicism, and both are subtractive. Outreach matters more than it sounds like it should. In 1977 you could print "wow" in a margin and start a subculture that has never ended. In 2019 you could publish that Borisov carried odd cyanide ratios and dust behaviors that should have made headlines, and the world would shrug because there were no good gifts. If Atlas is going to leave a mark, it will do it in classrooms first and funding committees second. That's the order in which the future tends to happen. The smartest question in the room is not, "What is Atlas?" It is what do we do next time? Next time, how do we not stare at a closed curtain at the moment the play gets good? Next time, how do we get a shard of machinery from Earth to meet an object like this before it's a memory? Engineers are already sketching answers on napkins. Tiny sails that can be kept in a state of readiness. Interceptors riding shotgun on other missions, ready to be flung. Networks of small scopes swarming the phase angles in a global choreography that isn't sexy but catches the glints we need. Policies that allow time to be moved like money in a crisis, because time is money in this business and it is the only currency the sky respects. There is a quieter, personal question under that. How do you live with a universe that gets more complicated the longer you look at it? You stop demanding that it be tidy. You stop punishing people for asking dangerous questions and start punishing sloppy thinking instead. You cultivate the nerve to say this might be intention, and the nerve to say right after it, or it might be 1,000 small blind pushes arranged into an accident so beautiful it wears the clothes of purpose. You teach your kids that wonder is not the opposite of rigor. It is the sibling that keeps it awake. The numbers will keep coming while all of this philosophy blooms and wilts. There will be new measurements of how brightness falls with distance. We will argue again over whether the slope is 2 like a reflective object or 4 like a source that shades itself as it turns. Someone will find a narrow spectral feature in archived data that we missed. Someone else will prove that feature is an artifact and will be thanked and then ignored because correction never gets the clicks. Loeb will publish something that makes rooms louder. Others will write sober caveats, and some will be read, and some will be thrown across rooms, and that is fine, because it means we are still alive at this.
You can use your imagination without getting drunk on it. Picture the surface of Atlas under a microscope. You will never hold.
If it is natural, maybe it is coated with glass made by a billion years of tiny impacts melting and refreezing a skin until it shines like a scar. If it is not, maybe it is layered purposely to shed heat and shrug off ions, a functional beauty designed by minds that understood radiation differently. Either picture is worth your attention. Both ask you to be larger than your first reaction. The social world will do what it always does when the sky bleeds into our feeds. There will be films and novels in a year and a half that pretend they saw this coming. There will be threads that claim agency cover-ups and threads that claim all anomalies are hoaxes. There will be people who take the opportunity to fight about whether we should ever reach for anything off-world again when Earth has enough pain to fund 100 lifetimes of work. You can be patient in the middle of that. You can refuse to let anyone turn your curiosity into their rage. One more difficult truth is worth holding without blinking. Even if Atlas is nothing but a strange comet with a lucky path, it has already done the work that only a true anomaly can do. It has embarrassed our models into being better. It has forced us to admit that speed is not only a parameter in trajectories, speed is a parameter in how a civilization learns. This visitor, by being rude, might have given us the push we needed to prepare for visitors we can touch. You do not need a conclusion to move. This is not a sermon with a last line that makes the choir hum. This is a map being redrawn while the party is underway. The lines behind you are still wet. The coast you think you see ahead might be cloud. It does not matter. You keep your hand steady and your head humble and your heart large. By the time Atlas disappears behind the sun and then reappears and then fades into the part of the dark where our machines cannot follow, we will either have learned enough to say something cleaner than we can say now, or we will have learned enough to say we still don't know in a way that does not scare us. Both are victories. Both are what grown-up science sounds like. So stand outside tonight, wherever you are, and look at the sky that is not going to tell you anything directly. Think about a thing from far away crossing our plane with the grace of a plan. Think about a sequence of planetary handshakes carved out of math by a rock. Think about light falling off too fast, a late spring coma, glints you can model and still wonder at, ice and organics old before our sun ever turned on. Think about tiny changes in old speeds making new futures. Think about the 5-degree courtesy that makes a stranger feel like it belongs at our table. Think about how we will be better next time because this time hurt. And when somebody asks you in a week or a month what you think it was, take the breath that science deserves. Tell them the truth that tastes both like fear and like freedom. It was either the most elegant accident we have ever measured, or it was the simplest technology we have ever almost met. Either way, it was a message.
Not a greeting in words.
A message in the only language the universe writes in, pattern and patience.
It said, pay attention. It said, be ready.
It said, stop pretending that uncertainty is a flaw. We do not control the corridors. We decide if we notice them. We decide if we argue well in their presence. We decide if we treat them like invitations or intrusions. Atlas is already leaving. The questions it pulled into our orbit are not. They will circle us for years, dynamic and bright and sometimes hard to look at. If we are lucky, the next time we see a corridor like this, we will have more than eyes. We will have a hand to hold out, an intercept to match, a new chapter written not in headlines but in the small text of instruments purring while a voice in a control room says, softly and without triumph, there it is. And when that day comes, when a tiny craft from Earth meets a thing from somewhere else on a path both of them earned, when light curves become close-ups and spectra become samples and metaphors give way to measurements, remember this season. Remember what it felt like to sit with not knowing and to refuse to turn it into noise. Remember that you lived through a moment when the sky offered you a hard gift and you did not drop it. Remember that the most beautiful line in any story like this is the one you can whisper at the end, to yourself and to whoever is listening. We showed up.
We learned. We got better.